Yeah, so we actually have two wonderful talks today, and we are going to be beginning with Protecting Georgia's Waters, presented by Dr. Ania Truszczynski. And then we'll be going on later to Callie Moore's talk, Biostabilization, Erosion Control Techniques. So that will be happening at noon. So we'll go ahead and get started with Ania's session. So Ania is the Assistant Branch Chief for the Watershed Protection Branch of the Georgia Environmental Protection Division. Ania previously served as EPD's Nonpoint Source Program Manager and Stormwater Unit Manager. Prior to joining the state, Ania served as the manager of Athens-Clarke County's Stormwater Management Program. Ania holds a bachelor's degree from Washington University in St. Louis in environmental studies with an emphasis in policy, and a PhD in ecology and evolution from the University of California, Davis. So thank you so much for joining us today, Ania, and feel free to begin your presentation.
Thanks, guys. Thank you for the very kind introduction. So I am joining you all on my phone because my computer ran into some issues. So I'm going to start by kind of going through the first couple slides of my presentation without the actual presentation, and then hopefully the computer will catch up with us here in a moment. So I really appreciate your all's patience and understanding. So I'm here today to talk to you guys about protecting Georgia's waters, and I really appreciate y'all logging in and taking time to have that conversation. The very first slide I wanted to show you, I am kind of sad I can't, because it is a really wonderful and chaotic picture of a watershed from the USGS that kind of shows all of the different inputs that come in to a watershed and that can affect our water quality. So when we're thinking about all of the different components, all the different parts of watershed management, we're thinking about some of the traditional point sources of pollution that folks are familiar with, something like a municipal wastewater treatment plant that has a specific point source and a pipe discharge that goes into a water body, or an industrial wastewater treatment plant that has kind of the same general schematic. You utilize the water for an industrial process, send it through all sorts of treatment, and then discharge it back into a waterway. But even thinking more broadly, that kind of traditional way of thinking about water pollution as coming in from one particular pipe or one particular point was expanded to include stormwater discharges as well. So you can imagine, for example, runoff coming off of a parking lot, picking up all the oil and grease and everything from a water body, and then moving it into a retention pond and getting back through that retention pond and a pipe into a water body. But the reality is that even though we have that kind of clean schematic, watershed management is much more complicated than that, thanks to the presence of non-point sources. So this non-point sources generally defined in the Clean Water Act as kind of anything that isn't a point source. So we're really looking at rainwater after a rain event kind of coming across the landscape and going through all of those different land uses and picking up any of the pollutants associated with that. So anything from logging practices, agriculture, residential development, construction sites, all of those can contribute non-point source pollution to our water bodies as well. And when you think about all of those different ways that pollutants can enter our watershed, and then on top of that layer, all of the different type of pollutants that we might be talking about, you get a really complicated picture, right? Because what you might do in a residential setting to deal with over-application of fertilizer is really, really different than what you might do if you're looking at an industrial facility with a complex process and water treatment and a specific point of discharge. So all of that is to say that the Clean Water Act, or that clean water really requires everyone to play a role. And this is actually explicitly contemplated in the setup of the Clean Water Act, which contemplates a role for governments, for industry groups, for non-governmental organizations, for watershed groups, and for citizens. All of these different entities play an important role in watershed management. And there are a couple of different things I wanted to kind of highlight before I go into the outline of the specific updates that I want to give today. So first are the federal and state regulations. You can kind of think of this as sort of setting a baseline for how we're going to handle watershed management. These regulations, which the federal and state governments have the authority to implement based on legislation, so the Clean Water Act at the federal level or the Georgia Water Quality Control Act here in our state, allows us to put forward these rules and regulations that specify requirements around regulatory programs. So this is really what we're thinking about when it comes to some of those permits for these dischargers, whether they are the federal National Pollutant Discharge Elimination System permits or NPDES permits y'all might be familiar with on the municipal side or industrial side or stormwater side, or whether we're talking about the state issued permits for things like land application systems or state programs for stream buffers and stream buffer variances. Now, on top of those federal and state regulations, we also have local ordinances. So local governments are empowered to make decisions about certain areas of water management and land management that's relevant to them. And a good example of this are the stream buffer ordinances, stream buffer protections that a lot of municipalities in Georgia have. So the state of Georgia, through the Georgia Erosion and Sedimentation Act, has a 25-foot buffer on water bodies with rested vegetation, warm water bodies with rested vegetation, a 50-foot buffer on trout streams, and then a 25-foot buffer on coastal marshlands measured from the JD line or jurisdictional line. There are some municipalities that have actually said, you know, we want to be even more protective of these waters, and we want to add another 50 feet or another 100 feet on top of what the state already protects. So this is a good example of how you can have a local ordinance that helps add additional layers of protection to specific water bodies. So once you have this kind of regulatory baseline, you need to have some sort of funding mechanism or way of thinking about actually implementing the requirements of those regulations. And the Clean Water Act explicitly contemplates certain types of funding, though of course the funding tends not to match the magnitude of some of the issues that need to be addressed. So what this group may be most familiar with is grant funding. On the federal side, the Clean Water Act creates the 319 grants program, which the states administer. And this program is intended to provide funding for the implementation of non-point source management best management practices. So anything from the installation of green infrastructure to the installation of agricultural best management practices, whatever is needed to address the non-point sources in that watershed. We also have a state seed grant program, which y'all might be familiar with, and these seed grants are intended to support the regional water plans. I'll get into the regional water plans a little bit more later, but really sort of the big takeaway from these grants programs is that they help us make real but incremental progress in the implementation of these plans to address pollution. What you may be somewhat less familiar with are loans, like the Clean Water State Revolving Fund programs that are run through the Georgia Environmental Finance Authority. These are intended primarily for municipalities to address wastewater treatment issues and ensure that water quality is protected through upgrades in facilities, treatment modifications, things like that. So there's that little bit of that funding component included as well. So once you know what the regulatory approach is, once you have some of those funding options outlined, it's also really important to kind of understand what is going on with water quality more generally. And that's where things like applied research, modeling, monitoring are all critical. So the state of Georgia has programs on applied research, on watershed modeling, on ambient water monitoring that all kind of help build that general knowledge base. We also have a number of partners that work with us, other federal agencies, other sister state agencies, as well as institutes of higher learning are all involved in the generation of this data and the generation of this knowledge. So once we've kind of assessed where our water bodies are, it's really important also to get folks involved through education and outreach. And again, we've got great partner organizations that do really strong education outreach work. But I also really want to highlight the work that's done by Georgia and specifically by Harold's group. Everything from Project WET, Water Education for Teachers, or maybe as Harold said yesterday, Water Education Today, which brings environmental science into the classroom and not only empowers the educators that are working with the next generation of environmental leaders, but also that next generation of environmental leaders themselves. When you have folks that really understand the watershed, they can be involved in making good decisions about that watershed. And I want to call out AdoptAStream in particular because that group is uniquely situated within that education outreach component, as well as within that actual applied research and monitoring section as well. The t-shirts for AdoptAStream this year, I think, have citizen scientist on the back, and that label is very, very appropriate. When folks first really kind of contemplated this idea of citizen science, there was a lot of excitement on the part of the scientists themselves of saying, oh my gosh, we're going to get access to so much fantastic data because we're going to have trained individuals out in the field collecting way more than I could just with my lab itself. But there was a lot of pushback on that model because even though those gigantic data sets are really, really valuable and having folks engaged and building that knowledge is really valuable, it kind of kept the ownership of the direction of the research project and the development of new ideas stuck in that ivory tower. And what's really exciting about AdoptAStream is it kind of breaks that down because AdoptAStream volunteer groups are created where folks have an interest. So the state of Georgia doesn't have a list of, here's some water bodies we want y'all to go out and test. The AdoptAStream volunteer groups themselves decide which water bodies they want to test. They decide which constituents they're really interested in testing for. And in that way, the groups are kind of developing their own research program. So it's a really exciting way to have both these really phenomenal data sets, but also this kind of on the ground, hey, we want to look at this particular body. We want to try to address this particular problem. And it's exciting from two perspectives. One is, coming from a local government background, I know just how useful the AdoptAStream volunteer group data can be in helping identify places that require more attention, more research, problems that really kind of need to be fixed. This was really well highlighted, I think, in the Red Flag Award that was given out yesterday during the AdoptAStream award ceremony, where you had volunteers identify an issue and actually work with Gwinnett County to get that issue resolved. That's a really powerful way of getting on the ground fixes, really. But it's also really helpful from kind of a broader statewide water management perspective as well. The data that's provided by AdoptAStream groups can be used and often is used as a screening tool to identify where to deploy additional state resources for monitoring, for modeling, for really understanding a particular watershed. So it's a really nice way of kind of getting both of those, that immediate local level impact and kind of that broader state level perspective at the same time. And then the last kind of component of the Clean Water Act and the way that different stakeholder groups can kind of engage in it that I wanted to highlight is the public process and public participation. So when regulatory actions are taken, whether we're issuing a permit or we're going through rulemaking or we're updating some guidance, we have a specific built-in public stakeholder process. And this is a great opportunity for folks to provide their feedback and provide comments and information for us so that the state can then incorporate that in the decision making. And I'm going to take one moment here to see if I can get my Zoom up on my computer because I am somehow seeing things pop up again on the screen. And if there are any questions before I go into the update, this might be a good time. I'll see if I can take a minute to get myself onto the computer.
You can feel free to enter your questions into the chat or unmute yourself if you have any questions at this time.
I'm glad that Anna highlighted the quality of the data discussion, which has been going on for years. I think that question's been answered if by the sheer reality of so much data has been collected. I don't know anyone in any watershed that doesn't encounter an issue or a problem that doesn't immediately try to go to the local AdoptAStream data and see what, if any, and often there is some, clues are available in the local data in terms of anomalies or absence of anomalies. So that's huge. The other thing that's huge is a subset of what she described. It's really made it a lot easier. It's really provided an in-house base of advocates. That's not a specific outright role for it, although it gets highlighted in the award ceremony. But when it comes to local policy and pressure on local government, and sometimes that pressure is welcomed by folks in local government that are perfectly happy to have pressure put on them to do things that they sometimes run into challenges doing inside their own bureaucracy. AdoptAStream has been key in that. It's the platform for so many things in Georgia. It's been a huge accomplishment. So no question, sorry.
I appreciate that comment. I think that is absolutely accurate.
We do have a question in the chat, Anya. Tim wants to know, do you find that some bodies of water are not covered and tested regularly because the support people get to choose their focus of testing?
So I think it's what we see is the result of some resource limitation. So there are water bodies that EPD and EPD's partners have gone out to, have done some monitoring on, but then haven't had the resources necessarily to come back in a timely manner. So what's fabulous about the AdoptAStream data is that if there's a water body that's being monitored and it looks like there's an issue, we can say, hey, we actually need to go out there and collect some additional data and see whether this water body needs to be listed. Or on the flip side, if we're seeing that we've got AdoptAStream data that's showing that a water body is moving in the right direction, we can kind of prioritize getting folks back out there to do some monitoring. This brings up kind of an important distinction between the kinds of data that EPD uses. We have regulatory data, which is collected by EPD or some sister and partner agencies, or data that's collected under a sampling quality assurance plan or a SQAP. We have a number of AdoptAStream groups that have SQAPs, a couple of municipalities that have SQAPs, but basically having a SQAP means that we can use your data for regulatory decisions, like the listing of a stream as impaired, or delisting that stream once it's met its designated use again. So if we don't have a SQAP, but we have really good quality data, then we can't make a regulatory decision on it, but we can say, hey, this is where we need to deploy additional resources so we can get that regulatory data and have that ball moving with that particular water body. So that's a good question. Let me see, I'm actually hopefully opening up Zoom on my computer now. As I do that, I'll go ahead and let you know the things I was hoping to provide updates about with you guys today. And again, I really appreciate how kind everyone's being about this weird technical issue. So I was hoping to provide updates today about the water quality standards. We're undergoing a triennial review, and I think that provides some useful information about where we are with our water quality standards. I wanted to talk a little bit about a specific contaminant of emerging concern, or PFAS, which I think some of y'all are familiar with as well. And then we're in the process of updating our regional water plans. So I wanted to give an update on that process, a quick update on public participation, and then a little bit of information about some recent rulemaking. The rulemaking is not very exciting, but I figured that this is a good time to provide that additional information. So if there are no more questions, I'll go into a little bit of background on water quality standards. And as soon as I am able to get into the meeting through my computer, I'll go ahead and switch to the slides so you can see that. So water quality standards, they are something that I think folks are really familiar with, especially people who are working in AdoptAStream, because this is kind of telling us where, what the target is for a particular water body. But I wanted to give a little bit of background and break it down. So water quality standards are made up of 3 components. There is the designated use. So that's going to be something like drinking water or fishing. Oh, perfect. Let's see if I can join with computer audio as well. Watch out for a reverb. Thank you all for your patience. So if the water quality standards, they're made up of 3 components, like I said, the designated uses, or what we want to use that water body for, basically, whether it's drinking water, recreation, fishing, whatever that may be. And then once we know what we'd like to use a specific water body for, we can develop water quality criteria. The criteria is specific to the designated use, the idea being that the standard for drinking water and the standard for recreation may look a little bit different. One of the examples here is that secondary contact recreation, for example, has seasonal limits for bacteria, while primary contact recreation does not. So that's an example of how we may have differences in our water quality criteria depending on what the designated use is. Now, these criteria can be narrative, so something like no floatables, or numeric, which is, with bacteria, for example, that 200 counts per 100 mil summertime for fecal coliform is an example of what we might look at with that numeric criteria. And finally, there's an anti-degradation policy. So basically, we can't be doing anything to lower the quality of the water. So the water quality standards kind of fit into the way that the Clean Water Act thinks about our watershed management, because they're really the start of the process. We've got our water quality standards, we've established them, we know what we want the waters to look like, but then we have to figure out, do they actually look like that? So we go out, we monitor the waters, we look at all of our data, and then we do the assessment. We say, okay, this is what we see in the watershed, this is what we think that, this is what we have determined the standard to be, how do they match up? And if the data that we collected shows that we're meeting our water quality standards, we say, great, this is supporting the designated use, we're really happy with this water body. And if it looks like the data shows us that we are not meeting our water quality standards, we say, okay, this water body is not supporting its designated use. And then we pop it on a list. We say, we have to develop a plan for dealing with this watershed. We want to make sure that we move from being impaired or not supporting to actually being able to support that designated use. That plan is called a TMDL, and I'll talk about that a little bit more on the next slide. But we implement the plan through permits and through non-point source best management practices. And then we ensure compliance by having a robust compliance program with that. So to do our monitoring, we have about 250 streams, lakes, and estuaries that we monitor each year. We also have wetland monitoring, biological monitoring, fish tissue, and facility compliance monitoring. We also measure stream flow at 325 gauges and groundwater at 177 wells. So when we do our assessment and we take that monitoring data and compare it with what the standards say, we pull all that together into an integrated report called Water Quality in Georgia, which is published every 2 years. The most recent one was just published in August of 2020. It's up on our website in both the traditional format and in a story map, which is great because that is really interactive and lets folks kind of dig into that data. For the waters that are not supporting, we develop a plan to get them back to supporting, and that plan is called the Total Maximum Daily Load, or TMDL. And that's basically a pollutant budget. It says how much of a particular constituent of concern can come from our point sources, how much can come from our non-point sources, and then what's the margin of safety we have to put on that to make sure that we actually improve water quality. And we handle that through permit limits on the point source side and through best management practices on the non-point source side. So to take this equation apart a little bit, the TMDL is the sum of all the waste load allocations for all the point sources and all the load allocation across the whole watershed and that margin of safety, or MOS. Those waste load allocations are implemented through NIPD's permits that are given to point source dischargers of both wastewater and stormwater. Stormwater has a combination of permit limits and best management practices. Wastewater, for the most part, is primarily effluent limit driven. On the load allocation side, we handle that through our non-point source management programs. So we have a statewide plan to manage non-point source pollution. And when I was scrolling through the list of participants, I noticed a couple of familiar names, folks who did participate in the update that we did back in 2019. And this plan covers a broad range of non-point sources across the state and sets specific 5-year goals and interim targets. These goals and targets are prioritized by EPD and by the stakeholders who participated, and identify BMPs that we think need to be implemented to help us meet our water quality goals. To help support this, we've got 319 grants, sort of how I mentioned at the beginning, that structure of the Clean Water Act. This is one of those places where there are some funding options to help meet those goals. So where are we with our water quality standards, the thing that kind of sets that whole ball in motion? Well, we have to do a triennial review. So once every 3 years, we assess our standards. Our 2016 triennial review was completed in 2018. The package was delivered to EPA and they approved most of it in January of 2021. They didn't take action on our proposed revisions regarding non-recreational water standard for bacteria and the new lake standards for Lakes Oconee and Sinclair. So under this triennial review process, we are going to continue to work with EPA and kind of assess where we are on those two things. We also had submitted a revision to our narrative water quality standards. We withdrew that. We want to take another look and do some more work with it, and we may resubmit that under the 2019 triennial review. So currently we are in the 2019 triennial review process. And there are a number of different things that we're looking at, but I wanted to highlight 3 things in particular that I think are of interest to folks here. One is we are looking at revising some of the designated uses for our water bodies based on the public comments received. We've received some nominations for water bodies to be designated primary contact recreation or other recreation based on knowledge that folks have of how those water bodies are used. We've got a number of watershed groups that are interested in reflecting the fact that some of these waters have swimming holes, some of them are being used as water trails, and kind of update that designated use. We are working with the folks who are nominating those water bodies, as well as with the point source dischargers who are discharging into those waters to assess that nomination request and see what options we have. So this is an ongoing process. But one that we've got some folks really involved in. We're also looking to update the bacteria criteria for fishing and drinking water, and so secondary recreational uses. We went through and in 2012, 2013, updated the bacteria criteria for primary contact recreation. So think about things like swimming, but our water bodies with secondary contact recreation, we still haven't changed that bacteria criteria. And it's important for us to take a look at this because right now we use fecal coliform, and fecal coliform was identified in the 1960s and 70s as a good indicator of contamination of human waste into our water bodies. But further research by EPA in the 70s and 80s identified that really fecal coliform is such a broad suite of different bacteria that it's better to use another indicator. So they propose E. coli for freshwater and Enterococci for salt waters. So we're looking now at ways to translate the fecal coliform criteria to E. coli for secondary recreation. And then the final thing I wanted to highlight is in 2019, EPA recommended criteria or swimming advisories for cyanotoxins. Cyanotoxins are released in a harmful algal bloom. So when we get a lot of rain and warm weather and a lot of particularly phosphorus coming in off of the landscape, we can see these algal blooms in various lakes in Georgia. And some of the algal blooms are do not produce toxins, are still an issue, of course. They have effects on the ecosystem, but some of them do produce toxins. These are the harmful algal blooms. And there are some real concerns about the effects to human health as well as to animal health. So when EPA first made this recommendation in 2019, we met with the lake managers, talked through how to notify folks about a possible HAB. We developed a web page, an initial notification flyer, and really got the ball rolling on that. But in this Triennial review, we're making updates to the notification flyer to make it easier to read. We're looking at translating it into Spanish as well. We're going to be hosting more meetings with the lake managers to establish acceptable procedures for sampling and possible beach closures. And we'll be coordinating with the EPD lab. So one exciting thing is that the EPD lab has developed the capabilities to run PFAS samples, but the same equipment that does that can actually look for cyanotoxins. So we are working with them to see if we can develop the capability in-house to do some of these analyses. We will definitely not be ready for this summer, but we're hoping to target next summer with getting some capability online at that time. We also need to work to determine how to incorporate swim advisories into our rules or listing methodologies. So where are we in the Triennial review process? Well, we had our first meeting in February just to talk about designated uses with the folks that were looking to make those designated uses changes. We also had a second meeting a little bit later in February to talk through more broadly what the Triennial review is looking at reviewing and accomplishing. The presentations from both of those meetings are available. I've got the website here on the slide. I'm sure that these slides can be shared if folks want them, and you can also reach out to me and I'm happy to provide the presentation. From March until July, we will hold additional public meetings and stakeholder meetings with a final one tentatively targeted in August. We are hoping to do rulemaking in the fall of 2021, so presenting the recommendations to the board. So if you're interested, like I said, feel free to reach out to me, or you can go to this webpage here and get additional information about the Triennial review. So moving from the constituents that we are, constituents of concern that are regulated into contaminants of emerging concern, the ones for which we do not yet have regulations. And one that is receiving a lot of attention right now are PFAS. These are a whole suite of chemicals, totally man-made, that are resistant to heat, water, and oil, and they're used in many consumer goods. I think one that a lot of folks are familiar with is Teflon, for example, nonstick pans. Those nonstick surfaces are due to PFAS. And even though there are thousands and thousands of these chemicals, two have really received a lot of attention and study, and those are PFOA and PFOS, two of the long chain PFAS. Peer-reviewed studies of laboratory animals and epidemiological studies of human populations indicated that exposure to PFOA and PFAS over certain levels could result in adverse health effects. So in 2016, EPA established a health advisory level at 70 parts per trillion for PFOA and PFAS in drinking water. And this is a lifetime health advisory level, and it is for PFOA and PFAS combined. So if you have 40 parts per trillion of PFOA and 40 parts per trillion of PFAS, you've exceeded that lifetime health advisory level. The lifetime health advisory level is really focused on drinking water, with the understanding that there are other sources of PFAS. Like I said, we've got nonstick pans, we've got food wrappers that sometimes use PFAS, all sorts of different possible sources. But drinking water is the one that EPA is most concerned with, and you see that concern kind of echoed by the states. To first get an assessment of how much of an issue PFAS was, EPA used their unregulated contaminant monitoring rule, or UCMR. The UCMR requires selected public drinking water systems to conduct monitoring on these emerging contaminants of concern. And that gives EPA information about the spread of the contaminant and also the level of contamination. In Georgia, we found hits for PFOA and PFOS in drinking water. PFOA was found in Calhoun, Rome, Somerville, Chatsworth, and Dalton, and PFAS was found in Rome and Chatsworth. Out of these, only Rome and Chatsworth were above EPA's lifetime health advisory level, and both municipalities worked with EPD to get those levels back down below the 70 parts per trillion. There's also been work done looking at PFAS in surface water. So we are looking primarily in the Coosa Basin, just based on where where in Georgia we have potential sources of PFAS. We know there's a lot of manufacturing up in this part of the state of textiles and carpets that uses PFAS in their process. So you can see here monitoring done by both EPD and EPA from 2012 up through 2019. The green dots here are where there are non-detects. There's no PFAS in the surface water. Yellow dots show a PFOA and PFOS above detect, but below the 70 parts per trillion. And red is where where levels have been identified above that 70 parts per trillion. So you can see that even though we're not seeing it in a lot of our drinking water, we do see some level of PFAS contamination in some of our surface waters. The monitoring from 2019 included a small creek that was used as a drinking water source for the city of Somerville. And preliminary analysis from that creek showed high levels of PFAS. So EPA and EPD conducted joint sampling of the drinking water of the city of Somerville in January of 2020. Results came back and showed levels of PFOA and PFOS in the finished drinking water, so the water that was going to customers, of 98 parts per trillion. So that is above that 70 parts per trillion lifetime health advisory level. Somerville took steps to notify its customers and identify alternative water sources, and then over the course of several months worked with EPD and EPA to install additional drinking water treatment. And as of November 12th, the health advisory for the city of Somerville has been lifted. So monitoring was done to show that the additional drinking water treatment is bringing the levels down below the 70 parts per trillion. Monitoring will be ongoing, and Somerville is continuing to implement various improvements to ensure that their drinking water remains uncontaminated. So given what we've seen in Georgia so far, EPD developed a PFAS survey. We are starting with the Coosa and Tennessee basins and looking at all surface water systems and all groundwater systems that serve above or more than 500 people. We are kind of following the UCMR3 approach, which is basically sending out sample kits to these systems and having them send the sample kits back to EPD for our test to do the analysis. So this is, this image over here is an image from our story map. Right now, the blue indicates the systems that are being monitored. The purple indicates systems that are not being monitored. They don't meet the size threshold, but which could be monitored if we find a cause for concern. These dots are slowly going to change color to green, yellow, and red as data come in. We have only just recently started getting sample kits back from different public drinking water systems, so we do not have any of the results yet, but we believe that those are going to start coming in pretty soon. So go to our story map and you can keep up to date with the PFAS monitoring. As we work through the Coosa and Tennessee basins, we will identify potential necessary investigations and look at moving into other river basins as well. Okay, so we talked about what's in our water. We can move a little bit to talking about planning, and what I want to highlight are our regional water plans. So the state of Georgia has 11 regional water plans, and you can see the planning districts outlined here on this map. And it really all started in 2001 with the Metropolitan North Georgia Water Planning Act. This act created the Metro Water District, and they were required to create and adopt 3 regional water plans, which they did in 2003. In 2004, the Comprehensive Statewide Water Planning Act was passed, and following that act, in 2008, Georgia developed and adopted a state water plan. The Metro Water District revised their plans in 2009, and then in 2011, Georgia moved from that statewide perspective to kind of a regional water plan perspective. Those regional water plans were adopted in 2011, and then the Metro District and the regions got on the same schedule in 2017, revising and adopting new plans, and we stay on the same schedule now. So these water plans are updated every 5 years. What's unique about them is that they include regional perspectives and needs, and they are used by EPD and GFA. EPD uses the regional water plans to guide water permitting decisions, while GFA uses them to guide decisions regarding state grants and loans for water-related projects. The Metro Water District is unique. Their plan is directly implemented through permits, and EPD conducts annual reviews to ensure that municipalities are in compliance with the plan. So even in between plan updates, the council stay active. There are obviously things going on with plan implementation, there are regional water issues that come up. So we do have periodic council meetings as well as joint council meetings to encourage collaboration across basins. But now the focus is starting to shift into more of that plan update. Now that we're really getting into 2021, we're moving into more of that plan update discussion. And the big deliverable that we've kind of hit now with the plan updates is our forecasting. So we have 4 different sectors where we create water demand forecasts that extend out to 2060 and kind of inform the updates to the regional water plans. They look at how much water we're going to need for municipal, industrial, energy, and agricultural uses. The municipal water demand forecast, the stakeholder input is complete, and I believe that this document is also right around completion. The target was February of 2021. Industrial and energy sectors are completely done. Stakeholder input's completed, the forecasts are done, and the agricultural water demand forecast is still in process. That's being done by Albany State and UGA, and we expect that to be complete in the next month. If you'd like to see these water demand forecasts, you can go to the website listed here at the last bullet. And you can also just go to the regional water planning website for more information. The councils really are focused on outreach efforts and improving plan implementation. So if you're interested in being involved, please do so. Get involved, provide your input. There's always a chance for public feedback and participation. You can sign up for updates at waterplanning.georgia.gov. And the website is pretty nice looking. I recommend that you go and check it out. You can look at your regional water plan, like I said, get the forecasting information and get updates on that plan update process. So speaking of public participation, I wanted to put out one reminder and one new thing. This is old news, but there was a National Pollutant Discharge Elimination System update rule, or NPDES update rule. And one of the things that that rule required was for states to update how they share in public notice information. And the rule allowed for the electronic distribution and posting of public notices for NPDES permits. And this seemed like a really good idea, so EPD took that idea and ran with it. We now have 3 new public listservs, one for permit notices, one for state water buffer variance notices, and one for water quality standards, TMDLs, and grants. So I encourage, if you're interested in knowing what EPD is up to, subscribing to those listservs. I am subscribed to all 3. It is not a lot of email, but it is really nice to get an update whenever permitting decisions are happening, whenever we're making updates to water quality standards. All of that information is useful. And if you want to subscribe, you can go to the website here and then just click on the sign up button and it'll walk you through the process. One other thing I wanted to highlight with public participation is that in response to the COVID pandemic, we have moved our public meetings to Zoom. And I can tell you that I definitely missed the energy of Confluence. One, I wouldn't have had the weird computer restart issue that threw it off at the beginning. But 2, there is something really, really special about seeing all of the different hands-on activities that occur, having the volunteers come in and participate and ask questions. It is just a very energetic and fun meeting. So we lose some of that by going to Zoom, but we don't lose as much when we have our public meetings through Zoom. When we've had guidance update meetings or rulemaking meetings or permitting meetings through Zoom, we have actually seen an increase in participation compared to when we had these meetings in person. And I don't know whether it's folks not wanting to fight Atlanta traffic or whether it's just easier to log in than to come somewhere in person or what it is exactly, but it has been really great to see participation on some of these meetings, in some cases double or even triple. So as we start moving back to something approximating normal, there is a chance that these public meetings through Zoom will continue to be an option just because we've seen such a great level of participation. And then the last thing is the rules update. And I'm doing this a little bit pro forma, just because it's always nice to provide an update on what EPD is doing. But we have 3 rules updates, and almost all of them are driven by either clarification or legislative actions. So the first one is in water efficiency. We have a requirement that all public water systems that serve at least 3,300 individuals demonstrate progress toward improving water supply efficiency whenever they renew their drinking water permit. This has been on the books since 2015. We inadvertently left out a class of systems called purchase water systems. So these are systems that don't have a water withdrawal permit, but do still provide drinking water. So we have a rule update that was just approved by the board in February to kind of close that oversight. So now we have clarification that public water systems, including purchase water systems, must demonstrate this progress. We also had some rule updates to our drinking water rules. We made changes to about 25, 26 different rules in chapter 391.3.5. And they fit into 3 categories. We had updates to address comments from US EPA to get final primacy approval of our rules. We had general cleanup and consistency with the current Secretary of State standards for state rule formatting, and then just a couple of state rule updates that are not covered by EPA's authority, but which we needed to make. And this was also approved by the DNR board in February of 2021. And the final rule update is for our erosion and sedimentation rules. We are making updates to implement Senate Bill 445 from 2020, which was passed to allow water authorities to be designated as local issuing authorities for land disturbing permits. Currently, it's just counties, municipalities, but now water authorities are in there as well. We also took the opportunity to clarify procedures for when a public variance project or project applicant changes after a public comment period has closed. So we will require, and this is consistent with what EPD has been doing, it is just making it formal, require a new public notice when there's a change in the location of buffer impacts, increase in buffer impact, or a change in project concept or design. Otherwise, we will handle the public notice on a case-by-case basis. If it doesn't fall into one of those 3 categories, though, generally it is something like a paperwork update. We're also clarifying that to be consistent with other Georgia state laws, any new application or any new entity other than the original applicant who seeks to execute a previously approved project has to submit a new application public notice. So this just gets us square with other requirements. The board will be briefed at the March meeting, and then we're hoping to have this go through a public process and go back to the board in June. And I want to just note that that would be the second public process. We actually completed the first public process on these proposed rule changes back in February. So there are still more opportunities to be involved, but we have already started going down that path. So with that, if there are any other questions, I'm happy to answer them. You can also reach out to me directly. My contact information is right here.
Wonderful. Thank you so much, Ania. We definitely always appreciate you keeping us up to date on current status of Georgia's waters and water quality policies. So thank you for that. I'm in Rome, so that information about the PFAS was mildly concerning, but I'm glad that they're getting a little bit more stringent with their regulation, working their way back down. So that's good to hear, at least. We do have a few questions in the chat, so we'll go ahead and start with Anne. Would like to have you clarify the differences between PFAS, PFOA, and PFAS with an O, I guess.
Yeah, absolutely. Oh, sorry. So the main difference, PFAS is kind of a broad category of chemicals. So you can think of it as kind of a genus. And then within that genus, there are many, many species. PFOA and PFAS are just 2 species. So they're just 2 different types of PFAS. It gets into chemistry that, quite frankly, is a little bit more complicated than I I can really get into a lot of detail, but there are just many different chains, many different combinations of these carbon, these CF bonds, basically.
Joe, thanks. I'm not super depth on my chemistry knowledge, but that was really helpful in kind of understanding that a little bit better. Thanks, Ania. Gretchen wants to know, is groundwater less likely to have PFAS than others, and the others than surface water? Sorry, that was a little confusing.
So that is a really good question, and I think in Georgia so far, the evidence seems to say yes. So you may be familiar that there are some concerns around private wells near Department of Defense facilities or near places where PFAS was manufactured. So things like up in Minnesota and Michigan, I think Wolverine and 3M are two cases where there is evidence that private wells have been contaminated by PFAS from these industrial facilities or military installations that really heavily used or manufactured PFAS. But in Georgia, we didn't actually have manufacturing. We've only, of the chemicals themselves, we've had manufacturing processes that utilize these chemicals. And we aren't looking right now at the private wells. We're really looking at the public drinking water systems. The public drinking water systems have deeper wells, and these deeper wells really go into areas where it seems like it would be unlikely for PFAS to get that deep. Now, there could be some specifics of the geology that could potentially affect a groundwater public drinking water system, but through the UCMR process, we found no evidence of groundwater contamination in Georgia. And, we haven't gotten data back yet from this round of monitoring, but right now, just based on the research, based on what we've seen, we don't think that that's going to be a common finding. We don't think we're going to see a lot of PFAS contamination in groundwater, but I'm saying this, I'm kind of equivocating a little bit here because the past data suggests it's not an issue, but we're hopefully in the next couple months going to get a lot of data that will get us kind of more of a fine grained look at that. And then I'll be able to speak more confidently. All of that will be up on our website, but basically based on what we know right now, I wouldn't anticipate seeing a lot of PFAS groundwater contamination for the public drinking water systems that pull from groundwater.
Great, thank you, Ania. And Victoria posted the link to some PFAS information from EPA in the chat as well, so you can use that for a little bit more information. Let's see, Matthew just posted this question. He said, I've been told that lab analysis of PFAS is cost prohibitive for many of the municipal water treatment plants to perform routinely. Can you speak to how EPD is processing these samples and expand on how EPD plans to mobilize this monitoring on a statewide scale?
Absolutely. So I think there are a couple of things. One is, the tests are expensive. Absolutely, the tests are expensive. I think that we're probably going to see a decrease in those costs as more labs are running it and as testing just becomes more standard and routine, but that's kind of a tough ask for municipalities right now to eat a cost and wait. For the PFAS survey that Georgia EPD is implementing right now, we are handling all of those costs. We send the sample kit out, the sample kit comes back, and then we run the test. For municipalities that didn't have any hits back in 2013 under the UCMR3 and that aren't coming back with hits now, I don't know that routine monitoring would necessarily be needed. I think if there was some reason to think that something has changed, like a potential PFAS source has moved in, or that there might be some change to the source water, at that point, additional monitoring might be helpful. But it's not going to be something, I don't anticipate it right now being something like an MCL at this point. I know EPA is making steps to make it to go down the path. But basically, right now we're kind of looking at this as kind of a rare testing event for the majority of facilities.
If we see something that raises a red flag, if we see levels of PFAS above non-detect, or certainly if we see them above the lifetime health advisory level, then we'd want to do more frequent monitoring. And we would work with municipalities based on their specific circumstances to address that.
Thank you so much, Ania. I think that's super helpful. I'm really glad that, you know, you're taking steps to make that, and it's so good to hear that EPD is such a big part of making our water quality amazing. I mean, I know that's our job, but it's really awesome. So thanks. I think we're kind of 5 minutes past 12, so we're gonna stop and take a break really quick before we move on to our next speaker of the lunch hour. I know we've gotten lots of comments in there about Ania, all your wonderful information. So thanks again so much for battling technology and being here with us this morning. We really appreciate it.
Well, thank you all very much. I appreciate talking to this group.
Thank you. All right, everyone, we'll plan to come back on at 12:10 to hear our next speaker.